morning, friends. Today we are going to discuss about matrices. You know well about matrices that we have this chapter in 12th class. Now, first of all, these are our session objectives, but we will discuss. First of all, we will discuss about matrices, the type of matrices, operation on matrices, transpose of a matrix, then symmetric and skew-symmetric matrix, and some exercises, some questions which we have in our NCERT book. We will discuss that. Now, about matrix. Matrix is a rectangular array of the numbers, real or complex. Now, let us suppose this array. You just look at this. We have some columns here. These are rows and these are columns. So, when we take this rectangular array of a number, whether real or complex, it is said to be matrix. Now, let us suppose I am talking about this element of mth row and jth column. Now, we are talking about m rows are here and n columns are here. So, if we are talking about this line, this is a row, and this one is column. Okay, so these are rows and columns. We have m rows and n columns, 1, 2, up to n columns. So order of this matrix is, what is order? In order we tell about rows and columns. Okay. Now we are telling you about order as we have shown the rectangular array. In it we have m rows and n columns. So the order of this matrix is m into n. Let's take some examples. Let us suppose here we have 2 rows and 3 columns. So what is the order of this? Yes, it is 2 into 3. Here we have 3 rows and 2 columns. So here we have order of B is 3 into 2. Then let's take one more example here. The matrix has 16 elements. What are the possible number of columns it can have? Let's think about factors of 16. The possible orders of the matrix then we will get is 1 into 16, 2 into 8, 4 into 4, 8 into 2 and 16 into 1. So then let's take one more example. Write the matrix given by a rule. This is rule. We are given with a rule. Then in this rule we have to take values of I and j. I is representing the number of row which we are taking and j is representing column number. Okay. Now let us suppose first row and first column. Then we have one element in first row and first column. Okay. Let's take one example. Move on. Let's take its solution. We have here I can be value of 1 and 2 and j can take the value of 1 to 3. 1 to 3. Then the order of matrix is 2 into 3. Order of matrix is 2 into 3. Here when we have this number A11, then we have to take I to be 1 and j to be 1. Okay, then we have 3 minus I is 1 and 4 minus j is 1. Then 3 minus 1 and 4 minus 1. Then when we calculate it, we take some LCM and then we calculate by just doing calculation, we get its value 5 by 6. Similarly, A12. When we put value of I to be 1 and then j to be 2, then we will get its value to be 1. Then 2, 1, we will get 4 by 3 and 2, 2, 3 by 2. Similarly, you can get the values of A13 and A23. Hence the matrices. This is A11, A12, A13, then 21, 22 and 23. You will get this matrix. Okay. Now this is your answer of this example. Type of matrix. Let's talk about type of matrix. Here we have only one row. It is row matrix. Then column matrix. Here we have only one column. So this is column matrix. Column matrix. Show previous slide. Yes. This is column matrix. Only one column is there. Row matrix. It is row matrix because we have only one row. Okay. Now move on to the next slide. We have zero matrix. Here we have all elements 0. If all elements of a matrix is 0, it is said to be zero matrix. Move on. Square matrix. If number of columns and number of rows are same. Then we have square matrix. As here we have 3 rows and 3 columns. So its order is 3 into 3. So this is square matrix. Move on. Diagonal matrix. When you have numbers in diagonals only and rest of the numbers are 0. If it is diagonal element, you have some number. And if it is other numbers, other position, we have 0. So diagonal matrix, let's take its example. Then let us suppose we are having this matrix here. In diagonal we have number 3, minus 4 and 4, and rest numbers are 0. So this type of matrix is diagonal matrix. I think you got my point. Move on. Then in type of matrix, some more matrices are there, like we have the scalar matrix. Here, let us suppose Aij, where Ij is alpha if I equals to j and 0 if I not equals to j. Means we have in diagonal some numbers, all numbers same. Then we say that this type of matrix is scalar matrix because here all numbers are same and all numbers are in diagonals and rest of the numbers are 0. So this type of matrix is scalar matrix. Okay, one more matrix, identity matrix. Identity matrix is a special type of scalar matrix where we have all the diagonal elements equals to 1. So if Aij, I equals to j equals to 1, then show previous slide please. Show me previous slide. Yeah, I3 it is 1 1 1 and if I take diagonal elements all 1 and rest of the elements are 0. So this type of matrix is identity matrix. Move to next slide. Equality of matrix. Let's talk about equality of matrix. Two matrices are said to be same. First of all, you have to think about their order. The order should be same. If they are same order, then we can say that maybe they are equal. But how they are equal if every element on one position is same as other matrix having in the same position. Let's take one example. Here A, B, C, D are numbers. Please show me previous slide. Here and in second matrix we have 1 minus 2 minus 3. Then A should be previous slide. Please. A should equals to 1, B equals to minus 2. Previous slide 3 minus 3, D 4. Then here we have A1, B minus 2, C minus 3 and D 4. So this is equal matrix. We're talking about equal matrix. So we have to take the same position numbers to be same as in other matrices also. Move on. Addition of matrix. When we are talking about addition, then again we should have same order. Then we can add two matrices. Okay, let's take one example. And when we are talking about addition, then the same position numbers add to the same position number of second matrix. Show me one example. Let us suppose we are taking one example A and B. Then this one will add with 2, previous one. 1 will add with 2, 3. Then 3 will add with 3, 6. Previous 4, 1, 5. And then 2, 5, 7. Similarly other numbers. So in this way you can add, you can subtract. But you should have same order. If you have same order, only then you can add, you can subtract. And when you are adding, you have to add first number by first number. Then second number by second number. Then third number by third number. Okay. You got my point? So this is equality we discussed. This is addition we discussed. One example we have taken. Then addition of these numbers A plus B. We got it. Answer. Move on. Multiplication of a matrix by scalar. When we have to multiply a matrix with one number, one scalar number, let us suppose 2, then we have to multiply that number 2 with each and every element of the matrix. Show me. See, here we have all numbers here 1, 3, 4, 1, 2, 3, minus 1, 1. Then we have to find what we have to find. Let us suppose we have to find 2a. Then this number 2 we have to multiply it with all numbers. Previous one, please. So 1 into 2, 2, 3 into 2, 6, 4 into 2, 8, 2, then 2 into 2, 4, 3 into 2, 6, then minus 1 into 2, minus 2, 1 into 2, 1 into 2. So we got answer of multiplication of a matrix with a scalar. We got its value. Move on, please. Properties of the addition. When we are adding some numbers, some matrices, A, B and C having same order, because otherwise we cannot add. Now let us take in one property, this commutativity holds, associativity holds, and if M and N are scalars, then M into A plus B equals to M A plus M B, means distributivity, previous one, and M plus N into A equals to M A plus N A. This is distributivity of a number, two matrices, and this is distributivity of a matrix, two numbers. These properties holds. These are the properties of the addition. Commutativity means if you add two matrices, you need not worry about order. Means A plus B and B plus A, you will get same answer. And then again, associativity is there. In bracket, if you add these two matrices and then add C, or else otherwise you take B and C together and then add A, again you will get the same answer. So associativity hold, commutativity hold. Okay, move on to the next slide. Let's take one example. Okay, this is x you have to find if y is this, and 2x plus y equals to 1 matrix we are given with. Then you have to put here the value of x. When we have y, this 3, 2, 1, 4, put value of y here. When we put value of y, previous one, this is 3, 2 minus, this is 3, 2, 1, 4, 1, 4. And here we have this equals to here, then minus 1, 0, minus 3, 2, then previous one, please. Now 2x equals to this matrix minus this matrix. Solve it. Then 2x equals to, you will get minus 4, minus 2, previous one, minus 4, minus 2, take it half. You will get minus 2, minus 1, minus 2, minus 1. This is the value of x. So in this way you can find easily the value of one matrix in equation if the equation is given along with matrices. Please move on. Take one example. This example you have to do yourself. A plus B plus C is a 0 matrix. We have A, B and C you can take, and then you have to take it to 0 and compare both sides. You will get your answer. This you have to do yourself. Okay, move on. Solution is there. You can see C is there, and then you have to add these two, and then you have to take this to be on right hand side. Then you will get value of C. Move on. 0, 0, 0, 0, 0, and minus 4, 1. This minus you have to give to each number. Minus 4, minus 1, 0, minus 3, minus 1, minus 1. You will get its answer easily. Okay. Move on. Multiplication of matrices. Now, multiplication we are discussing. It is you have to be very particular about what we are doing. Please concentrate on the board, because multiplication you have to do. When you have to multiply, then Aij you have to multiply Jk. Means the column number here and column and the row number here should be same. When we have here the column number of first matrix and the row number of second matrix same, then you have to multiply, and then you have to take sum of these numbers. Let's explain. Taking one example. Okay, what is the order of this A? Its order is 2 into 3, because we have 2 rows and 3 columns. And what is the order of this? 3 into 1. So when we talk about 2 into 3 and 3 into 1, 3 into 1. Okay, so 2 into 3 and 3 into 1, 3 is same. 3 is same. Then, because here 2 into 3, column number is 3. 3 into 1, row number is 3. So its column number and its row number should be same. Then you can multiply it. And in multiplication, what you have to do, this first number you have to multiply. First number multiplied by first number, second number multiplied by second number, third number multiplied by third number. Okay, so 1 into 3, 2 into 1, 2 into 4, and all you have to add. So 3, 2 and 8. 3, 2 and 8, you will get 13. Similarly, 2 into 3, 1 is minus 1 into 1 and 4 into 4, you will get answer 6, minus 1, 16, 21. So in this way you can multiply easily number of matrices. Maybe next. Properties of multiplication of matrices. If both sides are defined, then A multiply B, C, A, B multiply C, associativity holds here. Distributivity holds. Multiplication is distributive over addition. So multiplication of matrix is distributive over addition. These two properties hold, but commutativity will not hold. A into B not equals to B into A. Commutativity of matrices do not hold. Move on. Let's take one example. We have this is row, then we have square matrix here and column matrix here, and its multiplication is 0. You have to multiply it. How you have to multiply? First of all, multiply these two. Okay. When we are multiplying these two, then 1 into 1 and 2 into 2 and 1 into 1 and 2 into 2 and 1 into 1. This first number by first number. This row you have to multiply with this column 1 into 1. 1 into 1 is 1, 2 into 2 is 4 and 1 into 1 is 1. Okay, we got 6. This is similarly 1 into 2, 2 into 0, 1 into 0. You will get this answer 2. 2 into 2 plus 0 plus 0. Then 1 into 0, 2 into 1 and 1 into 2. So 0 plus 2 plus 2. You will get its answer 4. Now this is row matrix and this is column matrix. You have to multiply. First number by first number, show me. 6 into 0, 2 into 2 and 4x. So 0 plus 4 plus 4x equals to 0. 4x comes to be minus 4. X comes to be minus 1. We got its answer. X equals to minus 1. This is one question. I have taken it from NCRT. Move on, please. Thank you. Example 6. Now you have to do this question. This is with your homework. This is A cos alpha, sin alpha, minus sin alpha, cos alpha, and A square. You have to show this. I am showing you the solution and I am also explaining you. Move on, please. If A square we have to find, then move please. Then we have to multiply A with A. And in multiplication, what we have to do, this row we have to multiply with this column. Cos A into cos A cos square. Please stay on the same slide. Cos A into cos A cos square A, sin square A with negative sign, cos square A minus sin square A, we will get cos 2A. Then cos A multiply sin A and then sin alpha multiply cos alpha. So cos alpha sin alpha we are having here and sin alpha cos alpha is here. This is sin alpha cos alpha 2 times. So 2 sin alpha cos alpha is sin 2 alpha. Similarly, minus sin alpha into cos alpha and cos alpha into minus sin alpha. Okay, then you will get minus sin alpha cos alpha and minus cos alpha sin alpha. You will get minus sin 2 alpha. Similarly, when we are multiplying minus sin alpha with this sin alpha and cos alpha with cos alpha, we will get cos square alpha minus sin square alpha. It will be cos 2 alpha. So we got its answer. Move on, please. We got the same formula. A square comes to be cos 2 alpha sin 2 alpha minus sin 2 alpha cos 2 alpha. Okay. Similarly, one more example is here. A square minus k minus 2y. And value of a is this and y is this. Its solution is move please. A square. You can find yourself now. Row multiplied with column, row multiplied with column, row multiplied with column, second row multiplied with second column. You will get 4 answers here, and these 4 numbers are 1 minute please. Stay on the same slide. Stay on the same slide. And then k multiply scalar k with a. So 3k minus 2k minus 4k minus 2k. 3k minus 2k 4k minus 2k. Then a square is here, k is here, who gets value? I is identity, and identity is 1 1 which is 0. Move next slide. Move a square k minus 2i. Move put its value. This is the value of a square. This is k and 2i. Solve it. 1 3k minus 2. Move. So you got 3k minus 2 minus 2k 4k. 2k minus 2k minus 2. Compare these. Then you will get value of k. Value of k comes to be 1. How? 1 equals to 3k minus 2 So 3k equals to 3, k comes to be 1. Okay, if you take any of 4 values and compare it, you will get same answer, k equals to 1. You got this. Okay, so this is all about matrix. Today we have discussed each and everything of matrix. Maybe you all got each and everything, but I want to say, so we will discuss it in other video also of other concepts of matrix. Thank you.